thank you for the introduction. I will move the story it's in the same manner, but towards more conventional techniques like coagulation and use of preozonation on the same territory as we saw in the previous presentations. So I will start with NOM, natural organic matter, which are very common in Vojvodina waters. Groundwaters, and by itself they are not they're not a problem in the toxicity, but they have a very hard impact on the water management, the water distribution system, microbial growth, disinfection byproduct formation, influence on other constituents behavior, for example arsenic, increase in chemical demand during treatments, and so on. During the last 10 years, we are working a lot in Vojvodina region regarding NOM and removal of NOM in conventional and more advanced techniques. And Mr. Petruszewski knows that very well because we work together. And the other constituents in the waters I will present is, of course, arsenic. I have to point out that this arsenic is of natural origin in these waters, and also in Serbia, as Mr. Petruszewski said, it's maximum level 10 micrograms per liter arsenic, and all these waters have a lot more. I chose for this paper and this presentation waters which are not so loaded with arsenic. The problem, removing arsenic is not nowadays the problem. Removing NOM also sometimes yes, sometimes no. But when they are combined in the NOM arsenic in one water, as for example in Zrenjanin, Kikinda, and waters I will show, then that can be a big problem, and especially in Zrenjanin, that's the problem. But it won't be today's topic of my presentation. There are some, of course, best available techniques recommended by by American Environmental Agency. Among them, it's coagulation, also absorption, which were a topic of the previous presentations, and ion exchange. And the goal of this study was to optimize ozone dose to remove natural organic matter and to see what will happen with arsenic during coagulation in waters which are not so heavily loaded with arsenic but still have to be treated. That's waters from the municipalities Kulpin, Bački Petrovac, Manlić, and Glođan, so more near Novi Sad. We used in bench scale experiments, we tried to use coagulation with ferrous chloride and polyaluminium chloride, which are common coagulants used in coagulation experiments worldwide. The pH of the waters was not corrected. It was in the range of 7 to 7.5, and the preozonation doses investigated were in the range common range for the natural organic matter removal. We followed DOC, UV absorbance of 254 nanometers, of course trichronometers formation potential as a surrogate parameter for all the other disinfection byproducts and arsenic concentrations. And we can look the water characteristics. So the DOC is higher than recommended by the US Environmental Protection Agency. It's not a common parameter which is measured in waters and which is in our legislation. It's a permanent number, but the American Environmental Agency say if you have DOC lower than 2, then you are safe regarding disinfection byproducts, and all of these have higher DOC values. and also the higher trihalometal formation potential, of course, which indicates that in the real disinfection conditions there can be trihalometers and also other disinfection byproducts which are more toxic. And the arsenic, as I said, is not too high. Even in this Gaussian water, it's very low. But sometimes it can be high. In some cases, it can be higher than a maximum allowable level. Also, these waters are very rich in bromide, which can also complicate the things. These are already published data about the characteristics of the natural organic matter. So in 3 municipalities, the natural organic matter is half hydrophobic and half hydrophobic, and the Gaussian water is mostly 70% hydrophobic, and there is no humic acid in all of these waters by our analysis. So, as we expected, preozonation slightly improves the coagulation efficiency for polyaluminium chloride and ferrous chloride, and mostly in doses higher than 0.5 milligrams per milligram DOC, and of course that was strongly dependent on the water characteristics. So that's the one pro for the statement that we have to do the investigation in the specific water each time we want to use some technology. We cannot apply some technology without any previous investigations. Reasons why preozonation didn't affect much DOC is that it can be actually the preozonation degrades NOMs and reduces molecular mass, and that affects the coagulation process negatively. But of course, when you look the removal of more aromatic compounds here, with no doubt there is improvement for the UV absorbance removal, and by using preozonation. Also for the trihalometers, they're also very dependent. The removal of precursors of trihalometers is very dependent of water type, coagulant type, and ozone dose. And preozonation showed improved results for ferrous chloride coagulant and not for the polyaluminium chloride. Also, this means that most of the precursors are not UV absorbable on 254 nanometers. As far as arsenic concerns, coagulation was, of course, especially with ferrous chloride, of course, enough to lower the arsenic content in this water below the 10 micrograms per liter, and as far as arsenic concerns, preozonation was not necessary, and that was the expected result. But what we wanted to point out is that we need to do the experiments and to evaluate all the parameters during these preliminary experiments in each water, because although all these water have similar DOC values and similar arsenic contents and also similar bromide contents, still they were different during the processes and differently responding to the coagulants, whether ferrous or polyaluminium chloride. Thank you very much.